When you hear the word poison, what color comes to mind? For most people, it's a sinister green, a toxic purple, or perhaps the stark white of a suspicious powder. But the truth behind one of the world's most infamous and effective killers is tied to a color that is surprisingly beautiful, a deep, vibrant, and electric blue. Welcome to a journey into the fascinating and often terrifying history of cyanide. To understand cyanide, we first have to talk about art. In the early 1700s, a paintmaker in Berlin named Johann Jacob Diesbach was working late in his laboratory. He was trying to create a brilliant red pigment for artists, but fate had a different plan. He happened to use a batch of potash that was contaminated with animal blood. Instead of the red he expected, the reaction produced a stunning deep blue. This was the birth of Prussian Blue, the first modern synthetic pigment. It was a sensation, used by masters like Hokusai in the Great Wave off Kanagawa and in the uniforms of the Prussian army. But inside that beautiful blue lived a secret. Decades later, in 1782, a Swedish chemist named Carl Wilhelm Scheele began experimenting with Prussian Blue. He managed to isolate a new, highly volatile acid from it. He called it Blausäure in German, which literally translates to blue acid. Today, we know it as hydrogen cyanide or prussic acid. In a grim twist of irony, Scheele, the man who discovered it, is believed to have died from his own chemical experiments, potentially including exposure to the very toxins he identified. The word cyanide itself comes from the Greek word kyanos, meaning dark blue, forever linking this deadly substance to the color of its discovery. So why is cyanide so legendary for its lethality? To understand that, we have to look at how our bodies work at the most fundamental level. Imagine your body is a massive city, and every single cell is a tiny factory. These factories need energy to keep the city running, and they get that energy by using oxygen. Inside each cell, there is a specialized piece of machinery called the mitochondria, the powerhouse of the cell. Within those mitochondria, there's a crucial enzyme called cytochrome C oxidase. Think of this enzyme as the final gatekeeper in the process of turning oxygen into energy. Cyanide is like a saboteur that sneaks into the factory and jams a metal rod into that specific machine. It binds to the iron atom inside the enzyme, locking it up and preventing it from doing its job. When this happens, the cell can no longer use oxygen. This leads to what scientists call cellular suffocation. It's a terrifying concept because even if your lungs are full of air and your blood is saturated with oxygen, your cells simply cannot breathe it. They are surrounded by life-giving oxygen, but are starving for it at the same time. This is why one of the classic signs of cyanide poisoning is that the victim's blood remains a bright cherry red. The oxygen is still there, but the cells haven't used it. The heart and the brain, which are the most energy-hungry organs in the body, are the first to fail. If inhaled as a gas like hydrogen cyanide, the effects are almost instantaneous. If ingested as a salt like potassium cyanide, it takes only minutes. Because of this brutal efficiency, cyanide has been a recurring character in some of history's darkest chapters. Perhaps the most famous unsolved mystery involving the poison is the 1982 Tylenol murders. In Chicago, 7 people died after taking extra-strength Tylenol capsules that had been laced with potassium cyanide. The panic was nationwide. It led to the complete overhaul of how we package consumer goods, giving us the tamper-evident seals and do not use if broken warnings we see on every bottle today. Then there is the grim history of Zyklon B. Originally developed as a pesticide, this hydrogen cyanide-based gas was repurposed by Nazi Germany for use in gas chambers during the Holocaust. It remains one of the most horrific examples of how chemical knowledge can be twisted into a tool for mass murder. In 1978, cyanide was the primary agent in the Jonestown massacre, where over 900 people died after drinking a grape-flavored beverage laced with a cocktail of cyanide and tranquilizers. This tragedy gave us the chilling phrase, "drinking the Kool-Aid," though the actual drink used was a competitor called Flavor Aid. But cyanide isn't just a tool for tragedy, it's also a staple of spy lore and urban legends. We've all seen the movies where a captured spy bites down on an L pill or a suicide capsule hidden in a false tooth. While these did exist in reality, used by high-ranking officials during World War II, the reality is far less clean than the movies suggest. It's a violent, agonizing way to go, not the instant sleep often portrayed on screen. One of the most bizarre stories in the history of cyanide involves the Mad Monk of Russia, Grigory Rasputin. In 1916, a group of conspirators attempted to assassinate him. They supposedly laced his favorite cakes and wine with enough potassium cyanide to kill a dozen men. According to the legend, Rasputin ate the cakes, drank the wine, and nothing happened. He seemed completely unfazed. For years, people thought he had supernatural powers, but science offers a more grounded explanation. One theory is that the sugar in the cakes and wine reacted with the cyanide to form a less toxic compound called a cyanohydrin. Another possibility is that the heat from baking the cakes or the acidity of the wine neutralized the poison. Or perhaps most likely, the poison was old and had degraded into harmless potash. Regardless of the truth, the legend of the man who couldn't be poisoned only added to his mystique. What might surprise you most is that cyanide isn't just something made in a lab or found in a spy's tooth. It is actually all around us in nature. Have you ever been told not to eat apple seeds? There's a reason for that. Apple seeds, along with the pits of cherries, apricots, peaches, and plums, contain a compound called amygdalin. When you chew these seeds, your body's enzymes break down the amygdalin into hydrogen cyanide. Now, don't panic if you've accidentally swallowed an apple seed. You would need to finely grind and eat hundreds of them to get a lethal dose. But for smaller animals, it can be a real danger. It's nature's way of protecting the seeds from being eaten by pests. The most significant natural source of cyanide in the human diet is the cassava root, a staple food for over 500 million people worldwide. Raw cassava contains high levels of cyanogenic glycosides. If it isn't processed correctly, usually through a long process of soaking, fermenting, and drying, it can cause chronic cyanide poisoning, leading to a paralyzing condition known as konzo. It's a stark reminder that even our most basic foods require a deep understanding of chemistry to be safe. Despite its deadly reputation, cyanide isn't all bad. In fact, it's a cornerstone of modern industry. Every year, hundreds of thousands of tons of sodium cyanide are produced for one primary purpose: mining gold. In a process called cyanidation, a weak cyanide solution is used to dissolve gold from ore. It is so effective that it can extract gold that is invisible to the naked eye. While this has revolutionized the mining industry, it also poses massive environmental risks, as spills can devastate local water supplies and wildlife. And in a final, poetic twist of fate, the very substance that gave cyanide its name, Prussian Blue, is actually used as a life-saving medicine. It is the primary antidote for poisoning by heavy metals like thallium and radioactive cesium. It works by trapping the metals in its complex lattice structure, allowing the body to pass them safely. For actual cyanide poisoning, doctors use a different approach, often using a form of vitamin B12 called hydroxycobalamin. This molecule has a high affinity for cyanide, binding to it to form cyanocobalamin, which is harmlessly excreted by the kidneys. So, what is the truth about cyanide? It is a substance of contradictions. It is the color of a beautiful painting and the gas of a horrific tragedy. It is a natural defense for a tiny seed and a massive tool for global industry. It is an invisible saboteur of life and, in the right form, a life-saving medicine. It reminds us that chemistry is neither good nor evil. It is simply a powerful language that describes how our world works. Understanding that language, the blue acid and its secrets, is how we learn to respect the thin line between a beautiful color and a deadly poison. Thank you for listening. Stay curious about the world around you, and remember that sometimes the most fascinating stories are hidden in the things we fear the most.